Chapter 2, Section 3, Polynomial and Synthetic Division. So when we're working with polynomial functions, it's important to understand that polynomial functions are actually the end result of a bunch of different pieces being put together. Those pieces are called factors. And in order to break a polynomial function apart, you need to be able to take the factors out one by one. The process by which we do that, the operation we use, is division. Now it's helpful to already know what one of the factors are, and that's where we're going to start. This theme of polynomial division, we'll be revisiting this throughout the rest of the chapter. So we're definitely going to be building on what we start with today. So dividing a polynomial function by its factor. Now kind of a funny story from Calc 3 in my undergrad of college is there was some type of situation where we had to do like a very simple division problem, okay? Like we were dividing by 4, it was something like 65. And for some reason we were doing it by hand. And here we are, a bunch of college math majors sitting around, and we look at that and we go, it's been a while since I had to do a division problem. What does this look like? So I think the 4 goes into the 6. How many times would 4 fit into 6? That's 1 time. And then you multiply that 1 by 4 to get 4, and then you subtract 2, and then you bring down this 5. And then the 4, how many times does that go to 25? I think it's 6 times. And then you multiply again, you get 24, and subtract and 1. And there's nothing else to come down, so we have a remainder. So that becomes 16, and our remainder over our factor. And we kind of laughed like, wow, we're kind of dumb. We forgot how to do long division by hand. The reason I'm telling you this story is because long division by hand is pretty much how you do polynomial division with factors. It's the same setup, it's the same process. You even treat remainders the same way. So we take our polynomial and we put it under that long division symbol. So 6x to the third minus 19x squared plus 16x, forgot the x, minus 4. And then we're dividing by the factor, x minus 2. Now what we want to do is we want to figure out how many times does x minus 2 fit into this polynomial. Okay, kind of like how many times does 4 fit into 65. And we'll start by looking at our leading terms inside and outside. So we have this x, that's our leading term on the outside. We have this 6x cubed, that's our leading term on the inside. So we have to think to ourselves, okay, how many times does x fit into 6x cubed? So x times what, excuse me, x times what would give us 6x cubed? Now that would be 6x squared. 6x squared multiplied by x gives you 6x cubed. So now we need to multiply down. But this here is a binomial, 2 terms. So when you multiply down, you need to distribute 6x squared times x, 6x squared times negative 2. And then we need to subtract. It's very important to be organized. I strongly suggest when you do that subtraction, you put a set of parentheses around that so you are remembering that you need to subtract all of these terms. Now the 6x cubed minus the 6x cubed cancels out. We wanted that to happen. We're then subtracting a negative 12, so we're adding 12. So negative 19x squared plus 12x squared gives us negative 7x squared. And then in the long division problem, we drop the next term. We now drop that 16x. And we start all over, looking at leading terms. Now the x is still the leading term on the outside. negative 7x squared. That's your new leading term on the inside. So now it's that same process all over again. You ask yourself, okay, how many times does x fit into negative 7x squared? That'd be negative 7x times. And now we multiply, but because it's a binomial, you need to distribute that negative 7x. So negative 7x times x, negative 7x squared, negative 7x times negative 2, positive 14x. We're then going to subtract the results. Strongly encourage you to put that in a set of parentheses. So a negative minus a negative, those cancels out. That's what we wanted to happen. 16 minus 14 is 2x. Drop down the next term, and now you repeat the process all over again. Your leading term outside, your new leading term on the inside. So x times what would give you 2x? That'd be 2. So now multiply, but because it's a binomial, you have to distribute. So 2 times x, 2x, 2 times negative 2 is negative 4. And oh my goodness. What we wanted to happen, happened. Everything cancels out. We have nothing left over, and we are very happy. All right. So if you divide out this factor, because remember what I said, polynomials are a bunch of factors put together. If you take this factor out, this is what you're left with. And then it says, use the result to factor the polynomial completely. So what we have here is a quadratic. 6x squared minus 7x plus 2. This is a quadratic. Usually quadratics that we work with they're written to be easily factorable. So 2 sets of parentheses. The first 2 terms have to multiply to give us 6x squared. There's a couple of ways that could happen. The last 2 terms have to multiply to give us a 2. Really only one way that could happen. 1 and 2. And because we have a negative in the middle, that means both the 1 and 2 are going to be negative, because negative times a negative gives you a positive. So now for this 6, okay, factor pairs of 6. There's 1 and 6, there's 3 and 2. Well, this 7 isn't exactly a big number, okay? So I'm going to think we're probably going to use the 3 and the 2, and it's really a guess and check. We're going to see what happens, whether it's 3 and 2, or if it's 2 and 3, and if neither of those work, then it must be some combination of 1 and 6. So let's go ahead and try 2 first and 3 second. Now 2x and 3x, those give you 6x squared. Negative 1 and negative 2 give you positive 2. The outer terms multiplied together would give you negative 4x. The middle terms inside would give you negative 3x, and those add up to 7x. So we found the factors of this quadratic. So our completely factored polynomial is what we started with, factor of x minus 2, 2x minus 1, 3x minus 2. And we have our completely factored cubic function, starting with polynomial division. Once you have a quadratic, factoring that down using some methods that we really already know how. Now, just as a quick reminder, let's say this wasn't a 0. Let's say we had something left over. That means we have a remainder. You would treat it just like you did over here. Here we put our remainder over what we were dividing by. So if we had a remainder, we would just tack it on to the end over what we were dividing by, x minus 2. So there are more examples on this page. You can complete those, work through them, check my completed notes online to see how you did. My only note I want to give you on these is down here. I talk about placeholders. I just want to draw some specific attention to those. Using zeros as placeholders, it's going to help you stay organized. So, for example, this right here, x cubed minus 1, we're missing the squared term, we're missing the first term. So under that division, go ahead and write it out like I have it, x cubed plus 0x squared plus 0x minus 1. That's going to help you stay organized and not drop any terms. So you can do that under the division sign. You can also do it with what you're dividing by. Make this x squared plus 0x minus 1. There's a lot going on in these problems, a lot of mental math. The more organized you can be, the better. So, another method of polynomial division, which I find students like more because it's simpler, it's a little less cluttered than polynomial division, is synthetic division. Now, because it's a little less cluttered, that means you have to do some conversions at the beginning of the problem and at the end of the problem. But what I like to do is I like to kind of describe the movement of some math operations. Synthetic division has a bounce to it. Okay, and I'm going to walk you through that bounce. So the first thing we need to do, synthetic division only deals with the coefficients. And where you put the coefficients really tells you about what term they represent, because we will use zeros as placeholders. So where you have numbers listed tells you if they're x to the fourth, x to the third, and so on. So the first thing we want to do is just take the coefficients. So there's a 1x to the fourth, so we have a 1. There is not an x cubed term, so we use 0. A negative 10 on the x squared, negative 2 on the x, and 4. And then we're dividing by this factor x plus 3. Here's the first difference. Polynomial division, you divide by the factor. Synthetic division, you divide by the 0. So take that, set it equal to 0, x equals negative 3, and the negative 3 is what we're going to be dividing by. So how we start synthetic division is you drop the first term. So this 1 comes down. Then the movement you do, I have to call it the bounce and add. Bounce and add. So negative 3 is going to bounce down. It's going to be multiplied by 1. It's going to bounce up here into the arc there. And then you're going to add. So 0 and negative 3, it's negative 3. And then you just do that process over and over. Bounce, negative 3 times negative 3 is 9. And then add. Bounce, negative 3 times negative 1 is 3. And add. Bounce, negative 3 times 1 is negative 3. And we don't get 0, and that always makes me a little nervous. Okay, so I kind of look and I check it again. And the math all looks good, so that means we have a remainder. That's okay. So we did this conversion to synthetic. We got our answer. Now we need to convert back. Okay? So each of these numbers represents a specific term. Well, we had a quartic. We divided by x to the first, which means our result will be x to the third. If you have a quartic, you divide by a linear, you get a cubic. So this negative 3 is for x squared. This negative 1 is for x. This 1 is the constant. And we have our remainder. So we have our remainder over what we multiplied by. Or sorry, over what we divided by. So polynomial division, Much like long division that you learned in elementary school, you multiply, you subtract, you do it again. Synthetic division, you divide by the 0, you add vertically, and then you have to reconvert back.